record the meeting, and later on we will post on YouTube channel for the visiting speakers seminar series.
Go ahead.
Yeah, and it's my pleasure to introduce Professor Alcides Lopes Leão, and the research area is about the biomass and bioenergy and bio-based materials, currently working at the Department of Bioprocess and Bioengineering at Sao Paulo State University, Brazil. He has outstanding academic and collaboration record, which includes published more than 150 papers in journal, 7 articles in newspaper, magazine, 35 book chapters, and was the author for 4 books. He had been a visiting professor at the University of Wisconsin back in 1993. And I see in his resume there is many other things. So that just as of highlighting, he has collaboration with the FAO, and he has received many awards, including USDA Forest Service for unique contribution to the program Visiting Scientists. So with further ado, just Dr. Leo, floor is yours. Just please go ahead and start the presentation. And we will have 35 to 40 minutes presentation. At the end, we will have question and answering period. Yep.
Okay, thank you for the invitation. Thank you, Sophia. I think it's a good opportunity to really strengthen our links now. So when you start to talk with Sophia, that was almost 1 year ago. So we didn't realize that how successful this partnership would end up, you know. So that's I think is the first step. Now we're here. The next one, Sophia will be there. So that means our collaboration will be I hope so, an endless collaboration with a lot of fruits. So basically, I came from agricultural camps. Okay, it's like you here. So my college, we call School of Agricultural Science. So, and I'm the coordinator for this laboratory. The name Residual has 2 meanings: all for everything, my initials, as well the use of residues. Just to tell you a little bit about São Paulo. São Paulo is the most developed state. I can say São Paulo is like California for US, or maybe Ontario for Canada. So we basically represent more than 50% of the Brazilian scientific publication, and about 1/3 or more than 1/3 of the Brazilian economy. So that means São Paulo is really the locomotive for the Brazilian economy. Also, based on this funding and availability, so we have a lot of the higher education institutes. Okay, so that means public education there is for free. So doesn't matter if you are from São Paulo or any Brazilian state, so you have a free education at public universities. And also what is important to mention, that about 1% of the São Paulo state tax are dedicated to R&D. We have a foundation, FAPESP, I think is a state-of-the-art foundation in terms of research, and they receive about 1% of the São Paulo tax revenues. And also 1.5% of the São Paulo revenue are invested in technology. So this is good. So anyways, Unesp is a state. So unfortunately, sometimes, because it's very difficult to manage, but we're spread out in 24 cities. So you can see that's the Brazilian map. And in blue, you can see the São Paulo state map. So, and then you can see that you are spread out throughout the state. There is no place that we don't have an Unesp campus further than 100 kilometers. And right in the center is my town, Botucatu. So we are considered maybe the biggest agro university in Latin America. So for sure, we're on the biggest university in Brazil. And our budget for 2023 is about $1 billion US. What is important to mention here also, we have 200 at that time, 238 international agreements with more than 37 countries. So That means that we are really pursuing international collaboration. So
Brazilian Portuguese, I mean,
yeah, we teach in Portuguese, but graduates classes are in English. Some, not all of them. Not all of them. But the undergraduate is just in Portuguese, unfortunately. Yeah. So right now we have over 380 professors and about 35,000 students. So that's the.
And that too, because it was a Brazilian guy.
Yeah. And we have a lot of.
Sorry, Dr. Paul. I appreciate everyone if you mute your mics, then we will have question answering at the end of the session. Thank you.
Okay. So we have these numbers of undergrad and graduate programs. So we have at our campus 3 research farms, over 200,000 hectares available for research and teaching. So come down to our laboratory philosophy. I developed this word we call ecomenia or ecomany. That means we have to be sustainable, but at the same time, we have to be economic. So it's a counterpoint between wide capitalism and the pure sustainability or pure conservation. So that means we try to be in equilibrium, no? So the philosophy for our lab is that innovative technology, especially we have really devoted most of our time to technology transfer to companies. I think this is important because it's a way to pay back our taxes. So the motivation for not to work with anything that stress the food chain is like this slide. You know, you can see here a typical American family. They spend like $300 per week in food. And this is the African family, $1. So every time we stress the food chain, those guys will suffer. And this slide is the World Watch Institute. So you can see here that we have to find a way between degrowth in terms of carbon and also keep our standard of living. So this slide shows for the 80 trillion US dollars, how is the economy? So you can see here, North America is really fat, you know, it's very big. China is big too, so, European Union. You see Africa in the center here is almost nothing. So in terms of economical GDP. And poverty, on the other hand, now you see opposite. So poverty is growing, especially in Africa, in India, in South America. And then come up with the last one, which for me is the inspiration for us in terms of bioeconomy or bio-based economy, that's the biocapacity. So if you look here in this slide, you can see Brazil has the biggest high biocapacity in the world. And if you go together with Canada, so I think we can be very good partners because a lot of resources are common, like forestry or corn. Okay, so there is a lot of opportunities for us to work together. So the mission for us is produce high value materials. That's the last phrase which I like most. So it doesn't matter if it is for industrial scale, let's say automotive or biomedical or even military. So the important is that we produce something more valuable than just burning the biomass. We have several research areas at our lab, so I can point it out. Some, the biorefinery is important, natural polymers composites, another one, and nanocellulose is really key for us now in terms of performance. And the last one, which is important in terms of extension, is municipal solid waste recycling. So my lab is quite big, so we have 800 square meters. So most of the equipments are industrial scale, so I can say it's a pilot plant. And then some of the projects we have complete or are still ongoing on. So as you can see here, is a lot in terms of variation. For most of my projects are related to automotive industry, so most of them, but also we have some very original ones, like this one, erotic products using natural materials. So you can see that our group is very active in terms of convert biomass into valuable goods. So this is another list of projects. So in this case, we develop like use of alloy, which is probably you have here in Canada, is a very common plant. Also uses of the residues like banana, pineapple, and so on. Also, we did a lot of extension, as was mentioned before. I still working for FAO, so also for Common Fund for Commodities. So we do a lot of consulting for in terms of agri utilization, especially for least developed countries. So like say Haiti, Philippines, Mozambique, Colombia, Tanzania, things like that. And then we have now the idea that's mixing the bioeconomy with circular economy. And then we can say now is bio-circular economy. So that's the way to really get a better use of our resources. No? And then I can say that for sure that if you have this bio-circular economy, that should be the pillar for the sustainability. There is not another way to do that. Especially if you consider that many countries are developing, if they do develop exactly following the US pattern for consumption, there is no hope, you know. We cannot really supply such high demand in terms of natural resource or even energy. And now if you look at the Sustainable Development Goals, you can see that the biomass or agri-waste can represent really a good opportunity for us in terms of supply. In this case, also, the idea is to try to use as much as possible these agri-wastes before burning. So I'd like to point it out that burning should be the last option. Of course, in Brazil, is a lot of burn in terms of sugarcane bagasse or eucalyptus chips. But I still think that burning should be considered for municipal solid waste, not for the biomass in primary. Going back to specifically to Sophia's work, so this was done at my pilot plant. So I'm using now charcoal wastes to produce composites. So you can see here, so I'm adding the waste material from charcoal. I cannot call steel biochar because it was produced at very low temperature, but is a residues from the industry. And also here is part of our research now is Ivana is doing. So is developing the sensor, electrochemical sensors based on biochar. So in this case, we're talking about different temperatures of carbonization. So we start with 450 and we end up with 1300. So quite a high temperature. So that means the future, we don't know. So a lot of opportunities. What I can tell you right now that in terms of composites application, the charcoal or the low quality biochar was really helpful in terms of cost reduction and property improvement. So that's one example of a biochar using acornia. Acornia is as a wheat, is a plague that was introduced to North America coming from Brazil, but is everywhere is a problem. So in this case, Ivana developed some sensor using this material from pyrolysis of acornia. And then this is a very good example I'd like to really discuss in terms of why we should export biomass instead convert biomass into valuable goods. So this was a published this paper quite a few years ago. I think it was 2019 or 18. But anyway, here you can see how much is imported, added value into our commodities. So let's consider just like the coffee. Look, 2.45 for a retail price, and commodities only 3 cents. So beer, now, which is important too. So we have the price 0.86 cents, and the commodity price just 1 cent. So that means we should concentrate more on technology or R&D to develop new applications or adding value to our products. That's a very good example you can see here. So in terms of biomaterials, pharmaceuticals, feedstock, and energy. So energy is the lowest alternative. So that means we should devote our research in terms of a change from reject to residues. Reject means useless, okay? Residues sometimes usable in your own productive chain or in third parties, byproducts, co-products, and products. So that's, I think, is the main idea in terms of applied research into biomass sector. And here, I like this slide because here I use this word, negative cost raw material. That means something you pay, you have some dumping fees. So if you use such material and to develop a final product, so you see there is a big range between this red line here up to the green line final product. So this will be the margin for even profit or development. So, and then that's one example, because I have done a lot of work in terms of natural fibers. Like Brazil is top in terms of scientific publication, natural fibers. But you can see here, Canada also is a key player. So Brazil is about 6% of the publication around the world, and Canada is about 4%. So it's still okay for considering that the Canada is well developed, you know. In natural fibers here is not as popular as in tropical countries like India or Brazil. So here is my, I try to produce as much as I can, but as I was talking before, our conditions completely different, you know. So, and then that's the platform we're looking for our products. So forestry, that's the high quantities and low value. Medical, high value, low quantities. Automotive, I can say high quantities and middle average value. And aerospace or airplanes, that would be low quantity and high value. So that is the platforms we're looking for. Here is, we published this, I think, last year. How is the flow to produce nanocellulose? In this case, we have the nanofibrils and nanocrystals. So both of them have a high-end applications in terms of industry. So the process we develop, we call steam explosion, is like diving, you know? So you're diving at the deep seas, and then you come up and you explode. So exactly that's the fundamental for this steam explosion we use in your process. And then to do, after we do this steam explosion and to produce the nano, we have to blend it with something. And of course, this is not so easy. And then we use some natural vehicle, in this case, latex or rubber. So here you can see the plant on the right side, it's Formium. And on the left side, you see the nanocellulose we produce. So we have several ways to do that, but the right choice would be enzymes. So enzymes is really important for us, no? We develop our own enzymes. We went to our local forest, we collect fungi, isolate this fungi, and then we start activation, and we end up with some enzymes. These enzymes basically will supply the way to produce nanocellulose with less environmental impact, like the one with high acid or high basic conditions. And here we have sources, different plants. So you see banana tree, not the banana itself, but the tree of the banana, bamboo, sisal, coir, coconut. So several plants we have tests. Residues, especially for Canada, this one is important. So lignin, eucalyptus, primary sludge, this also is very important. Primary sludge is very important because it's a high quantity and low value material. So in this case, we have tested macro scale, micro, and nano scales applications. Another research we done there, we found that during the war, we had a war in 1800s in South America, was terrible, was the biggest war we had in Latin America. At that time, there was no soap available, and the soldiers used this plant. And then I realized, well, if the soldiers use that as a soap nut tree, that could be a good compatibilizer, a surfactant. So, and then we published some paper about this use of saponin. So you can see here the molecule for the saponin. And this is a very good slide because impact strain is very important, especially for automotive applications. If you look here, 0.8% of nanocellulose, we almost double the polypropylene property for impact. So that means doesn't matter if really to produce a nanocellulose will be costly, but it still will be valuable in terms of blends. This is a brand new results. So this was from last December, where we work for Volkswagen. I'm sorry, but this slide is in Portuguese. But the blue line here is the material nowadays used by Volkswagen. And the other ones are our new materials. So you can see that we are making something better than has been used today in the VW cars. Also, another point that's very important here, on the last bar here, is the material Volkswagen is using, and now our own material. So you see, we're matching their material properties. And besides the
Professor Leão, you mute yourself. Okay, you mute yourself.
He's muted, yeah.
You're not working. You muted yourself, please.
Sophia, do you have his cell number or something?
No.
Okay.
Can you hear me, Professor Leão? You mute yourself. No, please. Okay.
Can you hear me?
Now we can.
Now we can. Like, you need to go back probably a couple of slides. You were
Couple of slides. That's the one for.
I have here that one. Yes.
Volkswagen.
Your work was better. Yes.
This is okay. Okay. So yeah. This I was showing you the material. I was comparing between our material and the one has been used for Volkswagen nowadays. So we match their properties, but it's important that our material is lighter. That means the car will be lighter, the less fuel consumption and less carbon footprint. That's okay? I'll move. So, and then that was a good example from India, how very simple technology can make a lot of benefits, especially in the case, I like this example because a way to keep the water safe, you know. This message, I keep this message in my lecture for my students usually, you see, the competition. And this is from Tanzania. A friend of mine gave this to me. So that means that it doesn't matter if you're a lion or a gazelle, you have to run for your life. So that means doesn't matter if you are really a big lab or a big university or a really developed country, we still both have to run and to survive. So that means sometimes the only way to do that is through collaboration. The last one I like to show in terms of a proverb, I like this one. Somebody once asked me, where you are? I say, I consider myself in the middle because sometimes we manage things that we really do not understand, you know? And then what is important in this case, the word scenario. We used to be the one, the capital and the labor. Now we have the technology. So it's important for us is really to develop like our own technology. So ready to use it, not importing. No? So I think would be the case. In terms of biomass utilization, I keep the threshold for me is $80 per barrel. So if the barrel goes below $80, we're dead in terms of biomass conversion or biofuel or even bio-based materials. So because these guys, they're very competitive in terms of price, in terms of structure, scale. So that means we really have to watch the petroleum prices, no? That means a lot in terms of global sales, no? I'll go fast here because I'll make this available to you. So another thing we're discussing, we're talking about a CO2 asset. Sometimes before we consider CO2 as a problem, but now there is an opportunity. So several companies, including Bosch, are working in terms of CO2 conversion. But again, why I would say for us, CO2 is a problem? Because in our case, our CO2 is green. So it is completely different from the brown one that's based on the fossil fuels. So that's important for us to separate. It's not only the case of CO2. We have to really split it, green CO2 versus brown CO2. So I think this is important. If you put together, this will be no good for us, okay? So we consider this can be the new oil, né? So the carbon chemical. I skip this slide. I come up with this biomass concept, this slide here. So you see here, composting or energy are the lowest priority. So we have to really concentrate in produce something more valuable, like active chemicals, or in the case biochar, things like that, you know? Because here you can see here the price, just €1 per kilo for biomass as energy. If you go to pharmaceuticals, cosmetics, it would be $100 per kilo. There is one company, a Brazilian company, the name is Nature. These guys, they sell $1 1 gram for their cosmetics. So it's very valuable stuff, you know, that they get from the natural products. And then here is related to that slide I show you, the applied research. We have to move from the pre-treated lignocellulose into something more valuable. In this case, polymers, films, or adhesives. What's the driving force? The people. I think there is a lot of support for green products today that was not as available as before, no? So that means today the companies, the corporation will pay more for natural products than they used to do that. You know, I think we're facing the good momentum in terms of bio-based materials. And then why to use that? Because also they are sustainable. So they are cheap, and not in most of the case, and I can say maybe most of the case, but not at all. Sometimes they're not so cheap, but they have very specific tailor-made properties. So these are, you can see here, look at that. This eucalyptus tree is only 2 years old in Brazil. They ship that for energy. And then let's skip this. This is from my lab. So we have this reactor for pyrolysis. Also, we developed some biopolymer that's PHB from fried oil. Why is that? Because the fried oil cost, the people are dumping, it's not like here in Canada, they just dump fried oil into the pipes, and then the pipes are clogged up. So, and then the cost to clean that is quite expensive. So the idea was to use this fried oil to produce PHBs. So that's the description. Another research we done, we're using ash from rice husk to produce this material, hydroxyapatite. So this was, we published this paper, was for some dental facial surgery. So here is the basic behind. Another research we're using at polycarb. This was together with University of Toronto, Professor Mohini Sen. So we produce a PHB, different blends with polycarb. The idea was to replace those supermarket trays. You can see here different properties: wood flour, sugarcane bagasse, rice, sisal, coir, and different matrices. Airplanes, we're trying to introduce some our bio-based materials into Embraer planes. I think for next year, 2024, we will be able to do that. We're working now in terms of research, but I think for 2024, we do have one project available for them. So resins, we did that, producing phenolic resin from eucalyptus bark. So this is part of the idea to use this bio-based material. This is not my slide, it was from the internet. This is my slide, so that's the natural fibers applications. This was in Peru, Lake Titicaca. Totora is a fiber. That's sisal leaves. That's the way we grow the sisal, we dry, we clean. This is another fiber from Amazon. So we grow from the beginning, from tissue culture up to plantation, and this in consortium with eucalyptus. That's the fibers, the mats, the final products are here in terms of VW cars. They consider this a case of success. So that's the reason we're working together very close to Volkswagen. Another product for Volkswagen, this for Mercedes, for a bus company, Volkswagen, Mercedes, injection mold parts. Now there are several ones, injection mold. In this case, 50% plastics and natural fibers. This, we're working now with Ambev, the brewer company, to produce this material using coir fibers with polypropylene. This was made together with a Polish institution, Natural Fiber Institute was made of our natural fiber Curaçá. This, I bought this in Philippines, is made of barong, is made of pineapple. This is made at my university. Everything here is made there, so we have in our pilot plant. That's the profiles we have. Also, we did a lot of research in terms of veterinary applications. So for drug delivery, you can see here in the center a membrane. This membrane is for, the aim is to release like antibiotics at high levels. Also, we are developing nanocellulose. So this is to a skin replacement. And the last year, we're able to grow this nanobacteria in terms of tube. And the idea was to replace the trachea during the COVID. We tried to do that. It was a call from a Bill Gates Foundation, but we didn't have enough structure to test this material. So instead using a rubber, we tried to use nanocellulose. And then the future hybrid solution. And we call this was an interview from Industry Leaders magazine, and they say the rise of green plastics. I think now you are in the right, as I mentioned before, in the right moment for developing these green or basic bio-based materials. No? So in conclusion, we have to work very close in terms of cost saving, environmental benefits, and weight reduction. So if you work in these three aspects, we can say we are carbon safe in terms of products. So also, if you go a little deeper in terms of science, in terms of like nanofibers, nanocellulose, or even chemistry of lignin, we can develop a lot of products that could be able to replace the carbon-based one. Of course, scale up is a issue. Scale up is a issue. So, but of course, when you talk about a bio-based, like biomedical application, this is not a problem. The future for us, identification of new products, quality, consumers' perception, performance, and identification with innovation. So it's not only new products, but also innovation. Like a keyword today is nano. If you use this nano, you have identification with innovation. So I'd like to thank the funding agencies that we really depend on that. Unfortunately, as I was talking before, our last president was a disaster. This guy shut down most of our research funding, but we survived. So also thank you, Sophia and the host for the kind of hospitality and the invitation. And I end up with this messaging. I like to keep this slide running while you can ask me questions, okay? This is a good inspiration for us in terms of science. Thank you. I think I made on time.
Yes, thank you so much, Dr. Leo. And I forgot to mention at the beginning that Dr. Leo has a collaboration with Sophia, and she kindly invited so then we can listen to his talk today. And I don't know, my voice is... So open for questioning. Kathleen, please go ahead. Unmute yourself and ask.
Many thanks, Dr. Leo. That is so impressive and so encouraging. I am a professor in social sciences. I'm getting feedback.
Well, wonderful. Yeah, I think the social science works very close.
Goddard, can you turn your mic off? There, maybe that helps. Still feedback.
That's not from me. I'm not sure why we did.
No, it's not from you, but when it's better now. Sort of. So I would like to ask about your view of the future, because I think the circular economy is the way for us to proceed. And you spoke of consumer perception and consumer request for products that are reused and recycled and valorized of full materials. So do you envision a circular economy kind of rating on products in the future, like we do now with tracking air miles, or, that's one part of the question. And then also, are you working with social scientists?
Well, thank you for your questions. First of all, no, I'm not to work with social scientists. So, but because we are very close in terms of agricultural, that means we deal with a low, let's say, low background people, So I can say that it's not when you work with the industry people, technology sector like IT, it's different. When you work with agricultural people, they really have a low perception in terms of sustainability. So anyway, so the point is, I do believe, yes, the circular economy will be the way. I think my generation is lost. I can say our generation is lost. I have no hope. But if you consider the new guys, there I can see my son. He's teaching at his class. The people are teaching him in terms of sustainability, in terms of how important it is to keep the resources, and also now the repercussion or in terms of industry. You see the ESG. So many companies now are pushing. So I just gave a lecture for Volvo about a month ago, and they're really considering ESG as a key aspect in terms of the future of their products. So it's not only for the auto, but I think this will be spread out in terms of everything, in terms of final products. So like safe products, fair trade. So all of these, I think, will be important for the future. But for our generation, I have no hope. So I just see people dumping things on the highway. So for me, it's unbelievable. But I think maybe we need more. Personally, I do not consider environment education. You have to have education. So if you have education, of course, you'll be environmentally sound. So I think it's useless to say environmental education. We have to have education, point.
Nice, thank you.
Okay, Dr. Lope, would you mind to mute yourself and somebody else ask a question because of the echoing we see here? I think that will help. Looks like yes. Okay, thank you so much. And the next person, Himadri, go ahead, please. Unmute yourself on this question.
Okay. Good afternoon, Professor Leo, and I thank you for such a nice seminar. I'm very impressed about the extent to which you are using the biomass. I am a bit curious about, like you told in the slides, you created a sensor using charcoal-based biomass. So for what application you are using that sensor? Professor Leo, you have to unmute yourself. You're muted right now.
Could you speak a little bit louder again?
Yeah, you mentioned in your slide about the synthesis of sensors using charcoal biomass. I want to know a bit about their application of that sensor. And please unmute yourself, Professor.
Right. So yeah, specifically regarding to this question, Ivana's would be more appropriate to answer her because that's is a very research field. Ivana Cesarino is here, so she's the one that's responsible for this sensor development. But today they just published a paper using this sensor for ivermectin, cadmium, so several heavy metals, or we can say emergent contaminants. So this has, if you look at her CV, you see many of her publications relate to this field. Ivana Cesarino, co-authors of this presentation. So she has done a lot of research in terms of these hormones, pesticides, heavy metals, using sensors.
And Professor, I saw you are working on a project in which you are using nanocellulose from wastewater treatment plant. So what you are, Professor, you are muted.
Yeah, we have tested more than 25 different sources of nano materials. So, but we believe that the most appropriate ones would be something with high cellulose content. That would be easier than something with high lignin content. Okay, so in terms of enzyme consumption or even some chemicals consumption. So that means, of course, the first priority is circular economy, residues. And then in the second, it would be low lignin content.
Yeah.
That's all, Professor. Thank you.
Yeah. Let's move to the next question. Kathleen, do you have a question? Your hands is up, or it's from the.
Sorry, no, sorry, I'll take that down. Sorry.
Okay, that's good. Okay, any other question? Looks like no questions. I do have one question, Professor. Basically, my field is about methane emission from ruminant animals. And we had this discussion with Sophia on some other matter. So that I was thinking that any of these byproducts that you are using for different application, have you had the opportunity to collaborate with somebody to look for their methane mitigation potential on ruminant animals? Oh, you're muted.
Yes, yes. Unfortunately, we in our campus we have a veterinary school and medical school. Okay, so unfortunately, the medical school is quite difficult to work with them. They're too busy maybe, so they really do not pay too much attention in terms of the development of biomaterials. But on the other hand, the vet school are pretty open. So and that's the work we have done together. So we see these rats, and now we see dogs. And finally, we believe that in maybe next year, we'll be able to replace the meniscus using this nanomaterial. So the idea that we have is, let's start with the vet school, with the animals, and then later on, we can jump into the human biomaterials. So that's I think the strategy. We did a lot of research, I forgot to mention, in terms of dental. So we published maybe 3 papers using nanocellulose, replaced the titanium pins. This was done together with another Canadian university, Trent University, which is together with my friend Suresh Narayan. So that means dental is easy, veterinary is easy, human not so easy. I think it's like, for me, it's the same as airplanes. I have tried to go into the airplane industry, and no success so far, because this is burn, this is a low quality, this is low value. So the strategy, I start with the automotive, and now they approach us, the airplane industry approach us. So why not to try in the airplanes? I think we have to eat the soup by the sides, not by the center.
Yeah. Thank you so much. I will get in touch with Sophie to hopefully to see you in person and talk more.
Yeah.
Sophie, looks like you have a question. Please go ahead.
Okay. So thank you very much, Professor Leão. A very impressive presentation. I have 2 questions. The first one is technical one. I see you have done considerable work on this biocomposite. So in terms of biocomposite, did you have any observation this biocomposite might, because it's biodegradable, it might invite this kind of fungi or bacteria to eat them and negatively impact the durability?
Yes, I have done that because I have my own company. We're producing those WPC decks. In these decks, they are for external application. So rain or anything related to fungi. We can say that fungi comes after 17% of moisture. And the question, who comes first, the fungi or the moisture? No? But basically, when we use this biochar or even the biocomposites, the biochar is very interesting because of the surface area. So this means we can have some anchoring between the matrix and the reinforcement. So this improves the properties. But on the other hand, you have to have a good encapsulation of these bio-based materials. Because if you don't have such encapsulation, they will expand when exposed to moisture, and that means the dimensions will change. So imagine if you have a deck, and this deck start to change the dimension with some swelling, no? So that means we have to have a very good blend between the matrix and the bio-based material. If you don't do that, you fail.
Okay,
and how
thank
to
you
do
very
that?
much.
You can do that with some surfactants.
Okay, so when you were talking about the matrix, I think a majority is the resin, the synthetic
resin, yes,
polymer.
You can
So
see thermal.
basically, still you have to blend them. So what's the profile, the percentage, the composition profile?
Otherwise, it's muting my mic every time. So the products I show you for injection molding, we're able to do 50-50. 50% resin, and the rest is the biomaterials. No? On the other hand, when you go for profiles, in our case, we're using 30% fibers. 30% fibers, and about 18 to 20% calcium carbonate in organic filler, and the rest is the resin. So that was a good composition in terms of mechanical properties, cost, and density. So if you change it too much, you can have some problems in terms of mechanical properties. or processability.
Thank you so much. Thank you so much. The ratio is good. It's impressive. So the second question is the general question. It's well agreed we need to develop bioeconomy, circular economy. So what's your vision on this major barrier along this way to develop a bioeconomy?
As I mentioned, I think the petroleum price is the first one. So if you consider the petrochemical industry, there like our fibers, the natural fibers, is less than 1% of the whole polypropylene fibers market. So that means we're nothing for them. So they can dump us in terms of price, and they kill our sector in a few months or a few years. So that means we have to really watch the petroleum price. If the petroleum price goes below like $80, as I mentioned before, there is no hope for us to be competitive. But on the other hand, again, so the pressure in terms of environment issues are pushing more and more companies to use bio-based materials. So maybe we'll be the winner at the end, not only because the cost, but because the consumer's perception. That's my hope, you know. But always I keep saying we have several meetings. In fact, next week we have a FAO meeting about the natural fibers and products. And we have to say that we're not there because we're poor or because we're social, we have social benefits, because we're talking about the least developed countries. We're there because we're good. So that's, I think, the point. We're not in the auto industry or not in the airplane industry because we're social concern or because we're environment concern. We're there because our properties are good. So that's the point in terms of R&D. We have to be competitive in terms of properties, not only because you are social or because you are poor or because we need some support. So that's the point. We need more research. We need more critical mass in terms of scientists to develop good products, competitive.
Okay. Do you think a government incentive can help us with this transition process? Or eventually we have to rely on this kind of market as a driver? You muted yourself.
Who comes first, the egg or the chicken? I think the public opinion will push the government to develop such policy. So that's my hope that your government, when I say your, because ours was a disaster, but your government will be more sensitive to this public pressure in terms of circular economy, because the government is the #1 buyer in the country. So imagine if your government say, okay, we buy only curtains that's made of natural products. We buy only carpets made of natural products. This would be a good, very good demanding for the industry. So that means public opinion pressure the government. The government maybe put some laws or some standards, and the industry will follow. I think this would be a good way in terms of increasing the power of the circular economy or the bio-based economy.
Okay, thank you very much for sharing your view. Okay, I'm done. I'm good.
The last question, we have one more question. Rahel, please ask your question.
Hi, Professor Leo. Thank you for such a nice presentation. So I'm a Killam Fellow, postdoc fellow working under Professor Sophia. So I have two questions. So since I'm working on the synthesis of hydrochar for the water and wastewater treatment applications, so my first question is, I have seen in one of your slides, you have mentioned that you are working in the field of nanocellulose from the wastewater treatment. So I just want to know how you are isolating the nanocellulose from the wastewater treatment. What methods are you using for that?
Yes, this project was a forestry company. The name is Melhoramentos. Is a well-known company in Brazil. They produce pulp. Okay, so and they use the process they call thermomechanical pulping. They're not using the sulfates. So what they do, they just grind the chips with hot water. Okay. And then what they do, after they grind that, they release the wastewater. But during this process, what we did, we sorted out the granulometry of these particles into the water. So in fact, the nanocellulose was there. What they're just throwing away. You know, they didn't know that there was none over there. They're just throwing away that material into the water. What we did, we just filtering that material and collected the nano.
Okay, thank you, Professor. And my next question is, since I'm working on the hydrochar synthesis, so for especially for wastewater treatment and water treatment, and I want to know what are the main factors that can lead to low surface area of hydrochar or biochar during the pyrolysis or hydrothermal treatment. Professor, you have muted yourself.
I don't know if you're aware, but in São Paulo, we have a huge problems in terms of water pollution and water contamination. So, and then the public utility company, the water utility company, is using a lot of charcoal. They just spray the charcoal into the water to clean remove the turbidity and all other products into the water. So they use like tons and tons of this material, which is made from most of the cases from coconut. Okay, and the surface area is around 500 something around that. So that means a huge market in terms of use of biochar. Okay, so I think the last year this utility company bought about $10 million of charcoal, activate carbon, to dump into their reservoirs. But I'm not aware about the hydrochar property, so I never use. So what we did, we use only activate carbon. In fact, my master dissertation was about activate carbon from pine. So, but hydrochar I never used.
Okay. Thank.
Okay. Thank you so much, Dr. Leo, for a great presentation. And thank you so much, everyone, for attending today's event. And drive safe if you're driving and stay warm. Okay. Take care, everyone. Bye-bye.
Okay. Thank you, everyone, for watching us.
Thank you. Awesome.
Great session. Thanks so much.
Thank you so much. Have a good day.
Thank you very much.